Solving equations by factoring requires us first to know what a quadratic equation looks like. A quadratic equation is simply any equation that has a degree of 2. So remember, our degree of 2 means we have an exponent of 2, and the degree means it's the largest exponent. So an example would be x squared minus 2x minus 15. That would be in a quadratic expression. To make it an equation, we set it equal to some number. In this case, let's let it be 0. In order to be able to solve this quadratic equation, we're going to try to first factor x squared minus 2x minus 15. In this case, it does factor to x minus 5 and x plus 3. If I have two things being multiplied together, in this case there is a multiplication symbol here, we just don't show it. If these two things are multiplied together to give us 0, then we know that one or both of them have to be 0. So I'm going to take my two factors, x minus 5, set it equal to 0, as well as x plus 3, set it equal to 0. And now I have two linear equations that I can go ahead and solve. In this case, we can add 5 to both sides to get x equal to 5. Here, we can subtract 3 from both sides, and we get x equals negative 3. If I were to take both 5 or negative 3 and plug them in for my x's, I would see that I would get a true statement. We'll show 5 as an example. So I have 5 squared minus 2 times 5 minus 15. 5 squared is 25 minus 10 minus 15. And we want to know, does this equal 0? That's why I put the question mark above my equal sign. So 25 minus 10 is 15, minus 15 is 15, is 0. So 0 equals 0, so it does check out. We'll see likewise, if you plug in negative 3, you would also get 0 equal to 0. As we get more complicated within our quadratic equations, let's look at example 2. Here, let's give you 9x squared minus 24x equal to negative 16. There's a couple of things you want to notice about this problem. One, we have a leading coefficient that's not 1, and also it's not equal to 0. It's equal to a negative 16. So before we start, we want to take this negative 16 and make it equal to 0. So set our equation equal to 0. And the way we're going to do that is to just simply move this negative 16 to the left side. So we're going to add 16 to both sides. Combining like terms, there are no terms on the left side that we can combine, so we simply smash them together as 9x squared minus 24x plus 16, and on the right side we end up with 0. Now we're going to attempt to factor this. This does factor to 3x minus 4 and 3x minus 4 equal to 0. Notice our two terms are the same, our two binomials. So we don't have to write two equations. All we do is write one. So 3x minus 4 equal to 0. Solving for x, 3x equals 4, so x equals 4/3. And that's our solution. For example 3, let's look at a 4x to the squared plus 4 equal to 17x. Here, our linear term now is on the right side. So we're going to move that to the left side. So we have 4x squared. We're going to put it in descending order so that 17x is going to go between the quadratic term and the constant. Minus 17x plus 4 equal to 0. Now we're going to factor. Factoring, we get 4x minus 1 and x minus 4 equal to 0. We're going to take each of these factors, set them equal to 0, and solve for x. So in this case, we're going to add 1, divide by 4, so we get x equals 1/4. Here, we're going to add 4, so we get x equal to 4. And there's our two answers. Notice we can get one answer, or we can get two answers. The degree of our exponent is going to tell us how many solutions we're going to see. Here we had 2, here we had 1, but remember we had 2 binomials that were exactly the same. So we call this a double root. So we actually have 2 solutions there. Let's look at one more example, just for good measure. And let's get a little more complicated. Let's throw in a cubic. So let's look at 6x to the third plus 7x squared equal to 3x. Notice again we have a term on the right side. We need to move to the left side. So we're going to subtract that 3x over. We're going to end up with 6x to the third plus 7x squared minus 3x equal to 0. Notice we have a common term in each of our terms. So we can factor that greatest common factor out. Remember, the first rule or the first process is always look for a GCF. In this case, we do have one. Now I can go ahead and factor that trinomial that remains. We get a 2x and a 3x. This is going to be a 3 and minus 1. Now I have 3 terms multiplied together to give me 0. So now I have 3 things to set equal to 0. So x equals 0, 3x minus 1 equals 0, and 2x plus 3 equals 0. Solving for x, the first one's done for us, x equals 0. In the second one, we're going to add 1, and then divide by 3, so x equals 1/3. And in this one, we're going to subtract the 3 and divide by 2. So x equals negative 3/2. Notice I have 3 answers that x can be. If we remember from the previous example, we discussed the degree of the exponent telling us how many solutions or how many roots we have for this solution, for this equation. And notice we have 3, our degree is 3. And we have now solved our quadratic equations by factoring.